Okay, the rest of section 8.1 is on row echelon form and reduced row echelon form. Okay, so row echelon form, the first condition is all rows consisting entirely of zeros occur at the bottom of the matrix. So for example, if I had a row of zeros, 1, 2, 3, I put them at the bottom. For each row that does not consist entirely of zeros, the first non-zero entry is a 1. For each two successive non-zero rows, the leading one in the higher row is further to the left than that of the lower row. So for example, 0, 0, maybe I had 0, 1, 0, 3. Maybe I shouldn't have put a 0 there. Okay, 1, 2, 3, 4. This is made up. Okay, because there was a row of zeros, I put it at the bottom. The first non-zero entry in each row is a 1. This has a 1 as the first entry. This has a 1 as the first non-zero entry. And for two consecutive non-zero rows, so for this one and this one, the leading one in the higher row is farther to the left than that of the lower row. So this one is the furthest left. This one's less left. This is also row echelon form. And you can see this one is the furthest left, then this one, then this one. This is also row echelon form, and it's because there's a 1 here, and the first non-zero here is a 1 here. So it often makes like a little X pattern, an X, a diagonal of ones. But if there's a row of zeros, it would be at the bottom. Okay, now the reason we like row echelon form is because it makes it really easy to solve using substitution. So if I look at 5, this is in row echelon form already. If I want to solve this system, I automatically get that y equals 3. And if I go back to the first row, x plus 4, y equals 5, I can quickly solve for x using back substitution. So the solution to the system would be -7, 3, and that was very easy because it was in row echelon form. So for B, it's the same idea. It is in row echelon form, which means if I start with the bottom row and work up, I can do back substitution. So x, y, z, this is z equals -2. If I go to the second row now, I have y plus 3z equals 5. Okay, and then back substitution all the way up to the first row, I get x plus 2y minus 3z equals 10. And because it was in row echelon form, it was really easy to just substitute it in and solve it. Okay, so we're going to practice converting things to row echelon form. One thing to keep in mind about row echelon form is not a unique form. So you might have a different row echelon form than someone else, but it's representing the same matrix. When we get to reduced row echelon form, it will actually be a unique matrix. Okay, so if I want it to be row echelon form, I want this matrix to turn into, it can have a 1 here, which this does have a 1 here. I want it to have a 0 here. And my first goal is to get a 0 here. So I have to think about how I'm going to get a 0 there, and then I'm going to write the step I'm going to use to get the 0 there. Now I'm happy with the first row, so I'm going to leave that alone. Okay, now for the second row, I want to think, how can I get a 0 here using elementary row operations? So one way to get a 0 would be to add row 1 plus row 2. And I'm going to show that I'm adding row 1 plus row 2, and then I'm going to write the resultant here. Okay, so if I go back to the previous matrix, if I do row 1 plus row 2, 0, row 1 plus row 2, 6, row 1 plus row 2 is a 12. Okay, so if it's this 2 variable matrix, you want to get the 0 here first. Okay, now that I have the 0 here, I want to have a 1 here and a 1 here. I already have the 1 here, which is a coincidence. Getting the 1 there is the easiest step. Okay, I want to turn this into a 1 as well. So to turn this into a 1, I'm going to divide by 6, or I'm going to do 1/6 of row 2 from the previous step. So 1/6 of 0 is 0, 1/6 of 1 is 1, 1/6 of 12 is 2. Now this is in row echelon form, so I'm done. It doesn't ask me to solve it, and again, this is not unique, so you might have a different one than someone else. Okay, so for B, I'm going to do the same thing. I'm going to practice turning it to row echelon form. For row echelon, strategically, you want to get the zeros first. So since this is 2 by 2, I want to get a 0 here first. I'm going to worry about the ones later. The ones are the easiest, so I don't care about them. Okay, so I'm going to actually leave the first row alone. I want to figure out how to cancel this out using row 2. Okay, now let me see. If I were doing elimination, I would probably times by 2 here, and then I could cancel it with row 1. I'm still kind of doing elimination, so I'm actually going to times 2 on row 2, and I'm going to add it up with row 1. And the nice thing is I can do both steps at the same time. Okay, so if I do 2 times row 2, I get -2 plus row 1. It gives me the 0 I want. 2 times row 2, 2 times 1 is 2 plus 5, 7. 2 times 4 is 8. 8 plus 11 is 19. Okay, I got the 0. I got all the zeros I need. Now I just need to turn this to a 1 and this to a 1. And I save that for last because it's always the easiest step. Okay, so if I want that 2 to turn into 1, I divide by 2 or I do 1/2. So that's 1, 5 over 2, and 11 over 2. There's nothing wrong with fractions on these. Okay, and then for the second row, I want that 5 to turn into a 1. So I'm going to do 1/5, row 2. 0, 1, 19 divided by 5 is 19 over 5. Okay, this is row echelon form. It doesn't ask me to solve, so I'm done there. Okay, the last one for practicing row echelon form, I'm going to do a 3 by 3 where it has an X, Y, and Z. Okay, the strategy is a little more involved because there's more zeros to obtain. So eventually I want all of these to turn into zeros. I always start with the first column and try to get zeros here and here. And this strategy, it does always work. Okay, so I'm going to keep the first row the same. Okay, now I want to get a 0 here. Let me see, just like elimination, look for something that'll easily cancel. I could do row 1 plus row 2. Okay, so I'm going to do row 1 plus row 2, and I'm going to write the resultant in the second row. So 1 minus 1 is 0, -2 plus 3 is 1, 3 plus 0, 9 minus 4. So I got the first, that's 0. For the third row, I also want to get a 0 right here. So I want to cancel this out. I could use row 1 with it, or I could use row 2 with it. It doesn't matter. You just have to make sure you're using a different pair than you did the previous time. I think I'm going to use row 1. I could multiply row 1 by -2 and then add it to row 3. And this is not the only way to do it, which is why these are not unique forms. If I do -2 times row 1, -2 times 1 is -2 plus 2 is 0, which is what I wanted. -2 times -2 is +4, -5. -2 times 3 is -6, plus 5. -2 times 9, -18, plus 17, -1. And be careful. Okay, I have the zeros here, so I'm going to go to the next column. I want a 0 here now. Okay, so I'm going to leave the first row and the second row the same this time. 1, -2, 3, 9. And the second row I'm happy with for the moment. Actually, it has a 1 there already, which is kind of nice. Okay, now I want to get rid of this one here. So that's easiest to cancel with row 2 because it has the zeros. If I try to use row 1, this 1's going to mess it up. So I'm going to add row 2 and row 3. They happen to looks like they're going to cancel pretty nicely. So 0 plus 0, 1 minus 1, 3 minus 1, 5 minus 1. Okay, I'm almost in row echelon form. I just need to get a leading 1 right here. So I'm going to divide the last row by 2, and then it will be in row echelon form. 1, -2, 3. 0, 1, 3, 5. And then for the last row, I want to half it or divide it by 2. Half a 0, half a 0, half of 2, half of 4. Okay, now this is in row echelon form. If I wanted to solve it, I could solve it very easily, but I'm not going to right now. Okay, for D and E, I'm going to do the same thing, except for I'm letting you know ahead of time it's going to have no solution, and one of them will have infinite solutions, just so you can see what that looks like. And then we are going to try to do reduced row echelon form, which is a nicer, more eloquent form, but it's a little more work. Okay, whenever I start with the first column and I try to get zeros here and here. Okay, so I'm going to keep the first row alone. Okay, now I normally try to use row 1 with row 2 and row 1 with row 3 just to be safe. If you accidentally recombine your rows in the exact same combination, you accidentally create a dependent system. Let's see. What if I do row 2 minus row 1? I could have done vice versa. 1 minus 1 is 0, 2 minus 1 is 1, 2 minus 1 is 1, 2 minus 1 is 1. Okay, let's see. For the third row, I'll just do row 3 minus row 1. Not the only way I could do it. 1 minus 1 is 0, negative 1 minus 1, negative 2, negative 1, negative 2, 1 minus 1, 0. Okay, let's see, I got zeros here. Now I want to get a 0 here. So I'm going to leave the first row alone and the second row alone. Okay, now I'm going to use row 2 to cancel out my row 3. If I multiply row 2 by 2, I can cancel it. So I'm going to go ahead and do that. So 2 row 2 plus row 3. 0 plus 0, 2 minus 2, 2 minus 2, 2 plus 0 is 2. Okay, I'm actually in row echelon form right now because I have the zeros at the bottom, and the ones are still following the diagonal as much as they can before they hit the zeros. Okay, the conclusion of this though is saying that 0 equals 2, which is not true. So in this case, I can confirm that there is no solution to this system. Okay, for E, I'm going to do the same thing, but it's going to have infinite solutions. And again, it's just so you can see what leads you to that conclusion and then how to express your answer if we were solving it, which I'm going to solve it just because. Okay, I'm getting zeros in this column first, and I'm always going to start like that. I'm going to keep the first row alone. If you can also switch rows, so if there's a row you would rather have first, you could switch it. It just takes another step though, which is why I normally just leave it as it is. Let's see. Oh, okay, row 1 and row 2, I can just add them to get a 0. 0, negative 1, negative 3, 2. Okay, and then for row 3, I'll add that with row 1. 0, 1, 3. Okay, now the next move is I want to have a 0 here. So I want to cancel this out using the one above it. Luckily, they are going to cancel. Okay, but I'm okay with my first row. I'm going to be okay with my second row, although I could times it by negative 1 now. Okay, for my last row, what am I doing? I'm canceling out that 0, so I'm going to do R2 plus R3. 0, 0, 0, 0. Okay, so I can tell right now it's going to be 0 equals 0 is infinite solutions, but this is not actually in row echelon form yet because I have the 1 here. This is not a 1. I need there to be a 1 here. I have the zeros at the bottom, which is also good. So I'm going to go ahead and do one more step, although I could have done it on the previous step if I had foreseen what was about to happen. Okay, so I'm going to go ahead and multiply the second row by negative. So 0, positive, positive, negative. The third row stays zeros. Okay, now I'm in row echelon form because I have that leading 1 on my non-zero rows. So because 0 equals 0, these are infinite solutions. Okay, and if it's in row echelon form, because we canceled out the z, if you let z equals a, let z equal a, it almost always is the easiest way to do it, unless something else happens to be canceled. Okay, so if I let z equals a, z equal a, then on the second step, the second row, I write y plus 3a equals -2, and I can get the y value. And then if I want the x, I go back up, plus y plus 5z equals -3. Okay, and then if we were solving, we would still represent our answer in terms of parameter a as an ordered triple. Okay, so that's what it would look like if it was infinite solutions. Okay, next we're going to switch to reduced row echelon form because that's really the nice version that we like to work with. Okay, reduced row echelon form looks like this. Okay, so we have the zeros down here, and we have the zeros up here, and we have this diagonal of ones. Okay, this matrix on the left with the 1 0 0 0 1 0, that pattern is called the identity matrix. And it will come up again in other sections because it's a very important matrix. It's called the identity matrix because if I have it in this format, I can automatically get the solution without doing any work. So if I just look at this, it's saying x equals a, y equals b, z equals c. So it's basically solved for me. So if I can get it in reduced row echelon form, it's solved for me already. Okay, in terms of strategy when I do this, I often start at the same. I go with the first column here, and then I work in. But then I have to go back and get zeros in this last column, and then I work in from there. I'm going to do that strategy every time because it always works. Okay, I'm going to do two. I'm going to do a 2 by 2, and I'm going to do a 3 by 3 to show you both ways. Okay, to start it off though, let's see, this is 2 by 2. I want to get a 0 here. So I'm going to leave the first row the same. Okay, now the second row, I want to get a 0 here. I'm going to have to multiply both equations by something for this one to work. So I'm going to multiply the first equation by 3, the first row, and then the second equation by -2. And you are allowed to multiply more than one row and then combine them together in one step, although you could do it separately if it's easier. Okay, so I'm going to do 3 times row 1, so 6 minus 2 times row 3. 6 minus 6 is 0, and that's what I wanted here. I wanted a 0. Okay, but I have to do it for every column now. So 3 times 1, 3, minus 2 times -2. 3 plus 4 is 7. Okay, 3 times 5, 15. 15 minus 8, 7. Okay, I have a 0 here. I do want a 0 here. Okay, let me see. I can see on this row, if I divide by 7, it's going to make it's all divisible by 7. It's just going to make my numbers nicer. So you don't have to do this step here. It's often good to save getting ones till the end, but because I can see it's all divisible and it will probably make it easier for me to do the next step, I'm going to go ahead and divide 7 on the second row. That'll be 0, 1, 1. And that really and truly was to make it easier on myself. Okay, 0 here. Now I want a 0 here. Okay, so if I want a 0 here, I think I'm going to subtract the rows somehow. So how about R1 minus R2? There's more than one way to do this, but because reduced echelon form is unique, the reduced form will end up the same. So let's see, 2 minus 0 is 2, 1 minus 0, 1 minus 1 is 0, 5 minus 1 is 4. And the second row, I kept it as 0, 1, 1. Okay, this is looking good. I have a 0 here and a 0 here. I want 1s along the diagonals. I already have a 1 here. I need another 1 here. So I just have to divide the first row by 2. 1, 0, 2. And then the second row already had the leading 1. Okay, so now this is in reduced row echelon form. This is the identity matrix. If I wanted to solve it, it's 2, 1. It doesn't ask me to solve it, but it asks me to do all the work required to get to solving it. Okay, and this is a unique format, so if you were comparing with someone, you should have the exact same result. Okay, we're gonna do one more together. And this is because this is a 3 by 3. Although the strategy is gonna be the same, but there's more zeros to get, so there's more steps. Okay, I always start right here. So I'm going to try to cancel these out as my first step. I'm going to leave the first row the same. You are allowed to switch rows, but unless the first row looks terrible, I normally leave it alone. Okay, and the steps you choose to get there are up to you. Let's see, if I want to cancel that 3, I'm going to times row 1 by -3, and then add it to row 2. So -3 plus 3 is 0. -3, 0 plus 1, 1. 9 minus 2, 15 minus 4. And you might want to do this off to the side if mental math is not your favorite. Okay, if I want to cancel the 2, I'm going to multiply the first row by -2, and then I'll add it to row 2, or row 3. Okay, -2 plus 2 is 0, which is good because I wanted a 0. Okay, 0 plus 2 is 2. 6 plus 1 is 7. 10 minus 2 is 8. Okay, I have my first column of zeros. Okay, now I'm going to try to get a 0 here. So I'm going to leave the first 2 rows the same. Okay, now if I want to get a 0 where the 2 is, I want this to cancel, and I need to use the row above it. So I'll multiply the second row by -2. Okay, 0 plus 0 is 0. -2 plus 2 is 0, which is good. -14 plus 7 is -7. -22 plus 8 is -14. Okay, this looks good. Okay, now what? I actually want, oops, I didn't want to write, I just want to circle. I want zeros over here next. But I'm debating. I'm going to go ahead and divide this. It's not a necessary step, but it's just to make the numbers easier for me on future steps. So to me, it's worth the extra step. Let's see, divide by -1/7, just to make it easier. 0, 0, 1, 2. Okay, now I'll try to get the zeros in that last column. And I'm working out and then I work in. So let's see. So I can, now that this is a 1, it's easier for me to see. I can times 3 to cancel that, and I can times -7 to cancel that one. Okay, so I'm going to times 3 on row 3 to cancel with row 1. 0 plus 1 is 1. 0 plus 0 is 0. 3 minus 3 is 0. 6 minus 5 is 1. Okay, now for the second row, I'm multiplying by -7 to the third row to cancel with the second row. 0 plus 0 is 0 plus 1. -7 plus 7. -14 plus 11. Okay, and then the last row was fine. Okay, so it looks like I already got it in row echelon form. Reduced row echelon form, normally I would have to get a 0 here on the next move, but since it's already turned into a 0, then I'm done. If I wanted to solve this again, this would be 1 comma negative 3 comma 2, and it would be a unique form. But since it does not ask me the answer, I will stop there.